One of the simplest kinds of functions, but also one of the most important because it's ubiquitous in the world of applications, are lines. And so we're going to take one lesson just to learn more about lines and make sure that everyone is solid on them. If you think about what a line is, first of all, let's just take a Cartesian plane again. You can have lines of various sorts. A line just means anything like this. It has to be a function, so this right there would not be a line which is a function, but all these other ones would be. You can have lines that are constant and various things like this. And if you think, well, what is it that distinguishes one line from another? It's two things. One is the placement. Of course, you could have this line and you could have this line right there, and they're parallel to each other. They have the same slope, the word that we're going to define here in a moment, but they're positioned differently in space. And then of course you can have two different lines that go through the same point, but they have different slopes. They incline at a different rate. But once you have those two things, once you both know a point that the line goes through and you know what the inclination, that is the slope of the line is, you have no choice but to have just one line. That uniquely determines a line. So let's first define what slope is, and then we will use that to show how you can uniquely get a definition, equation for a line. So slope, sometimes called rise over run, is what you get by just taking 2 points on the line. Let's call these points x1, x2, or y1 rather, x1, y1. And the point x2, y2. So there's 2 points on a line, and given those 2 points, we find the slope of the line just by basically taking the change in the y values, in the vertical values, which would be in this case y2 minus y1, and divide that by the change in the x values, x2 minus x1. There's x2, there's x1. So the rise is this quantity, the run is this quantity, and so when you divide the one by the other, you have what's called the slope. And for whatever reason, I remember my calculus teacher said it's maybe because the word slope has an m in it, but we often use the letter m to indicate the slope of a line. So that's the slope. That's all there is to it. So so if the slope is like this, that's going to be a positive slope, because if you take this is going to be large, y2 is larger than y1, and x2 is larger than x1. So these are both positive quantities, and so m will be positive as well. If you have a line like this, then it'll end up having a negative slope. A line like this is going to be a rather large slope. That might have a slope of 3, for example. The rise over the run is 3, whereas one like this maybe is, 1/2 roughly, or maybe even 1/3. So you can kind of get a sense of what the slope of a line is. So that's probably something most viewers here are familiar with if you've had an algebra course before. So now, given that you know the slope, let's use that to uniquely get the definition of a line. Say, suppose we want what is the equation of the line passing through some point, let's say passing through the point AB, and with slope of m. Okay, it passes through the point AB and the slope is m. What's the equation of the line? I like to answer this question because, as I say, to me, if you think of a line as something which passes through a point and has a particular slope, then you just very quickly can find the equation of the line. And here's how you do it. Suppose this is your point right there. There's your point AB. And suppose this is the line that goes through that point. and the slope is m. Okay, how do we find the equation of it? Well, it's easy. Basically, the equation of the line is just all the points xy. It's all the points in the plane xy which fall along this line, which make a particular statement true. And so what statement is it that has to be true? Well, if the point xy is on that line, if indeed the point xy is on that line, since we know that AB is on there, we know that this ratio right here, namely y minus b divided by x minus a, has got to be equal to the slope. And so if you multiply both sides through by the denominator, you get this. And that's by far my favorite equation for a line. A lot of students use these slope-intercept form, things like that. But this one just works very well because quite often what you really know about a particular line is you know a point that it goes through and you know the slope of it, and you want to find the equation, and there it is right there. And you don't even have to memorize this. All you do is you just think of this picture. It's the line that goes through this point, this slope, and so y minus b over x minus a is equal to m. Multiply it through, and you have your equation. So once you have that, we can find various equations of lines. For example, find the equation of the line passing through let's say 2 points, 2, 3, and 6, 10. Okay, find the equation of the line passing through the points 2, 3, and 6, 10. Well, notice we only have one of the two things we need. Just to remind ourselves again, here's the equation of a line. Passing through this point. Well, we have 2 points, so no problem with that, but we don't have the slope. However, we do have 2 points on the line, so we can easily find the slope. So the slope is going to be what? 10 minus 3 all over 6 minus 2. Okay, because those 2 points are on the line, so the change in the y values over the change in the x values, which is going to be what? 7/4. And so there's the slope. Once you have the slope, you can use either one of these points. Might as well choose the one with smaller numbers to find the equation of the line. So it's going to be y minus 3 is equal to 7/4 times x minus 2. And so there's the equation. Quite often you want to solve it for y. And so to solve it for y, we get y is equal to, let's multiply through, you're going to get 7/4 x, and then 7/4 times 2 is going to be what? Negative 2 is going to be negative 14/4, and which is going to be negative 7/4 x minus 7/2. Okay, and then finally, oops, I'm sorry, this was y minus 3 over here. And then finally, if you add 3 to both sides, you're going to get y is equal to 7/4 x, and then you're going to have minus 7/2 plus 3. 3 is the same as 6/2, so it's going to be minus 1/2 by the time you're done. So, so there's the equation. If you wanted to sketch the graph of it, the graph would, without going into too much detail, if the x value is 0, the y value is going to be negative 1/2, and then the slope is 7/4, which is just a little bit less than, or a little bit less than 2. So maybe something like that. You can plot more points on the line if you like. Let's try one more just for practice. Find the equation of the line through the point -3, 4 and parallel to the line, I don't care, 3x plus 5y is equal to 8. Okay? Find the equation of the line going through this point and parallel to this line. Well, two lines are parallel if they have the same slope. So the first thing we need to do is to find the slope of this line, which we can do. If we solve it for y, we're going to get 5y is equal to -3x plus 8. Divide by 5, you get y is equal to -3/5 x plus 8/5. So there's the slope of this line. I want that same slope, but I want it to go through this point. So you can just go y minus 4 is equal to -3/5 times the quantity x minus a -3. X minus a -3 is, of course, the same as x plus 3. So you can leave it like that. If you want to, you can solve it for y again. That's going to be, what, -9/5? And I keep forgetting my constant over here. And now I add 4 to both sides. So it's going to be y is equal to -3/5 x. 4 is the same as 20/5. 20/5 minus 9 is going to be plus 11/5. So there you go. The only other thing, we won't do another problem, but the only other thing that you maybe should know about lines is that if two lines are perpendicular, then their slopes are the negative reciprocals of each other. For example, if the slope of this line was 5/3, then the slope of this line would be -3/5. Reciprocal means you flip them over. Negative, of course, means you take the opposite of it. So, so if I had asked, find the equation of the line through this point and perpendicular to this line, you would have, well, look at there. You would have first found the slope of this line, which is -3/5, and then the slope we would have wanted for our line would have been 5/3 instead. And you would have gone from there. So that's basically all you need to know about lines. That's the essential things, and then we'll use that as we go on in calculus. That's it.